of Electronics and Communication Engineering. On behalf of St. Joseph's Institute of Technology, I am here to volunteer for today's session. Now, I would like to extend my first and foremost gratitude to our Honorable Chairman, Sir Dr. B. Babu Manoharan, our Managing Director, Ms. B. Jessipriya Ma'am, and our Director, Sir, Mr. Sasishekar. And it's my pleasure to welcome Dr. G.S. Udayakumar, Sir, the wonderful speaker of today's session. And I thank you, sir, for making your presence here. And our beloved principal, Dr. B. Ravichandran, sir, for giving this opportunity to conduct the webinar. I would also like to extend my gratitude to our head of department, Dr. C. Nyana Kaunsalya ma'am, staff in student affairs, and Dr. G. Rohini ma'am, lab affairs, for their ceaseless support. Now, I'll be sharing a few words about our speaker, Dr. G.S. Udayakumar sir. Dr. G.S. Udayakumar sir is basically electronics and communication engineering with MBA marketing, ME medical electronics, PhD in biooptical engineering, completed in College of Engineering, Anna University. He have just completed Master Social Work through IGNOU. He have 32 years of experience in various fields in IT, over 12 years of design and development experience, and in teaching he have 20 years of experience. He have published more than 201 international journal papers and presented papers at various international and national level conferences in different engineering colleges. He have initiated to start various IEEE technical student branch chapters such as Communication Society, Antenna and Propagation Society, Industrial Electronics Society, Engineering in Medicine and Biology Society, Broadcast Technology Society, Computer Society, Computational Intelligence Society, and Control System Society in our college. Thank you, sir, for joining us today. Before we start the session, I would like to tell a few instructions to be followed by the participants. Kindly post your queries and questions in the chat box and they will be discussed with the speaker at the end of the session. The attendance link will be posted at the end of today's webinar. Now, I invite a speaker of the day to kindly start the session.
Thank you, Blissy and Dhanush.
Yes, sir.
So today's session, the topic will be process of innovation development, process of innovation development, and technology readiness level. That is TRL, technology readiness level, and commercialization of lab technologies and the technology transfer. The topic itself related with our core branch, electronics and communication. So what we are going to do next 1 hour duration, what is today's agenda? In the last workshop, I shared 9 different ideas. So as a student studying in electronics and communication engineering, what is next step? So I put across 9 different ideas. What is our immediate thinking? How do you develop? How do you convert all these ideas into a useful product to the community? So what is the next level? Idea is put across all the student. Our immediate step, we must frame different groups based on different ideas. So 9 ideas shared to you. The immediate step you must approach, and you must start initiation based on each and every idea with the faculty members and also student group. Because whatever I shared to you, all the ideas very useful to public. I think you all of you know very well. Okay, if you are thinking about Chennai city alone, because of severe rainfall, how we affected, how to overcome from these difficulties with a useful thinking and useful idea shared to you. The first idea is nothing but city water mapping and distribution system. If you're thinking about this particular idea alone, I think all of you know very well, and you are traveling across all the part of the city by using your Google Map very by using your Google Map very effectively, including foreign people. They are also traveling with the help of Google Map alone. So if you have Google Map, I think it is very easy to implement that particular idea, and you can convert that one into useful product by linking different streets with one particular domain. So that is the one process of innovation development and the technology readiness level. The technology readiness level is nothing but what are the technologies we are studying. For example, Internet of Things and electronic circuits. All the students are studying electronic circuits. Those who are joining EC branch. In the electronic circuits, whenever we are starting various circuits and various ideas to you, well, no, that may be ordinary transistor biasing circuits or diode biasing circuits or field effect transistor circuits or semiconductor field effect transistor circuit, complementary metal oxide semiconductor field effect circuits, CMOS, FET. All these circuits are, we gathered all the information inside our classroom and inside our lab. Okay, so the whatever we studied inside our lab, we are going to implement practically for all these purpose. How do you convert the technology into a useful product to the public? So that is the word commercialization of lab technologies and technology transfer. See, most of the country purely depending on technology. So how to develop technology, how to enhance ourselves by learning different technologies available on the internet. Then slowly you just develop one particular circuit for one particular application. That is city water mapping and the distribution system. Then what are the sensors you are going to design? So that is going to be where you just think continuously and focus yourself with one particular idea or novelty or innovation and convert that one into useful product to the public. So when it is ready in your hand as a product, then you can go with commercialization of that particular technology. That is going to be your technology transfer. Most of the electronic engineers, those who are working in the industry, they used to develop different type of products, and at the end of the day they will go with the technology transfer. With the help of technology transfer, they will get one huge amount that is required present day students. See why we are insisting including first year student. So whenever you are entering into curriculum, electronics curriculum, they have to concentrate in our domain. So usually I used to think each and every student is going to be one product based on our branch, core branch. So whenever you are entering into first year, first semester, whether you opt with the help of your parent or in your own, I want to study electronics and communication. What is the outcome based on yourself? At the end of the fourth year, you must go with the minimum 10 products in your hand. That may be very simple circuit. For example, if you are designing ordinary charger circuit for your mobile phone, you can feel this is developed by me. The circuit is available inside the charger. It is my own circuit. I never copied from anywhere. Then I told you one more idea to you. Solar cell using thin paper. Solar cell using thin paper. Why can't you convert that one into charger for your mobile phone? So automatically the cost will be minimized, and you can carry anywhere very easily. Nowadays, charger is one of the major problem. And what about your battery? Battery available in your mobile phone. For battery also, I told you one idea, that is face mask can be converted to useful energy source. Wastage. So many wastage available across city. Very huge wastage. I think we are traveling across OMR, and if you are traveling through Durpakam to that Kamachi hospital, around 750 acres occupied with the waste material. You just think how much wastage is available in Chennai city alone. Actually, whether you know or not, in Germany, in one particular place, the people converted all waste material into useful energy sources. That particular city is called as a green city. We are keeping everywhere dustbin. There is no dustbin at all. All the waste materials are converted into useful energy source, and with the help of that one, they are supplying electricity to entire city. So what are the steps involved? Okay, we'll go one by one. So how to focus ourselves with the technology development, and that must be useful to our country. If you're focusing on Chennai city alone, then we may be example for other cities in India. People should learn from us whatever we are doing. Okay, so what are the steps involved in innovation? So just I'll go through with the PPT also, because in the last time I didn't focus well with the PPTs. Now, so what are the 5 pillars of innovation? You just see the circle and small circles, step by step approach. So development process innovation. The first step going to be your idea. Then you just focus that particular idea so many times. Think. How to develop this one? How to concentrate with a variety of circuits available across the world. The people are sharing nowadays everywhere. I told you what are the hobby circuits available for electronic engineers, and different websites also I shared in the last workshop. So based on that, you can think continuously, and you can start with the initial step. So 5 pillars of innovation. First going to be, okay, so what is your first pillar? What about your platform and module design? Platform based design, module commonality. Okay, so what is the platform? So for example, if I want to develop a circuit by using ordinary spice. So those who are studying second year and third year, they know very well spice. And in digital electronics, simulation they used and they developed and they got very good output while doing different experiments. And same approach should be continued based on your idea also. First, you must choose platform. I want to work on this particular platform to develop this particular circuit. You just draw the circuit with a different thinking, different components. You can change as per your own thinking. There is no need of copying from other circuits. So if you are developing like this, automatically at one stage, the circuit will be entirely different from others. That is going to be innovation. I think you can understand. So what is a circuit and how to modify that circuit as per your requirement, as per your idea, as per your innovation, as per your novelty, and convert that circuit with a useful result. I think using simulation, we can get a very nice output and we can verify also. There is one Tinkercad software. Using Tinkercad software, the people are using different designs by using a recent board, Arduino board, Arduino Nano board. Okay, all these boards are available. Just pick and paste, and you just connect a few connections as per the circuits available, and you can verify the result. Then you can proceed with the next step. You purchase that particular component and you just implement that concept. So if you are concentrating with the one particular circuit diagram, so for example, I will show one particular circuit diagram, and I will share that one also, what to do in the next step. So how do you design a circuit? Okay, how do you test that particular circuit? schematic. So this is one circuit I'm going to show to you, and what we are going to do with the help of this particular circuit. I think it is visible to you. So I told you different simulation softwares are available, and now this particular circuit can be implemented using one particular platform. That is your initial step. I have chosen one platform, and I just whatever components available in that particular simulation software, everything available in the general PCB. I design this particular circuit, then I want to simulate this particular circuit for getting result. So that is the way we should start ourselves to develop any product. Don't worry about outcome, whether you are getting output or not. Don't worry about all these things. You just initiate with one particular circuit, and you just concentrate and with the trial. The people, those who are inventors, based on different concept, different technology, don't think that there are experts. That's why they developed all these things. They focused based on that particular idea in real time, and they understood all the circuit concept, and they changed different components as per the requirement, and you just simulate and see the result. Simulation results will encourage you to proceed further and to do the analysis based on this particular circuit. We must initiate. We are the creators. We are highly responsible for our society, not others. Electronic engineers are highly responsible for so many products today. If you're thinking about Internet of Things, more than 10 billion products are available. Who is responsible? Electronic engineers are responsible. Others' contribution is very, very less. Your contribution will be very high. I'm just telling about a big component, and start with these type of work. I'm not asking you to design IC itself, but in other countries, engineering students are designing IC itself. For example, OR gate. You're studying OR gate in digital electronics. In other countries, they are designing that particular IC and seeing the performance of that particular IC and functions. But what we are doing, we are just verifying based on that particular IC function. Okay, so where there is a lag, so how to focus ourselves to get useful product. Okay, so next I'll move with one more step. So that is platform and model design. Then the next step, cultivating innovators. Cultivating innovators. How we are going to cultivate innovators? So there is a human resource development and project management system. So cultivating innovators. See, there is a team of people working, and like your lab experiments, how you are distributing work to you? 4 students per particular experiment, or 5 students, one particular experiment. One student will be performing very well. because he's trying to get the output based on circuit given to him or her. In the group, one student will be getting output, the other student sitting and observing. So whenever we are conducting experiments for your lab, we used to distribute, I used to tell, don't concentrate with the only one student. If 5 students are there, if 5 circuits are there in your one particular experiment, each and every circuit should be performed by each and every student on rotation basis, so that there should not be any failure at all. End of the day, all the 5 students will perform very well in the university examination also. This is a practice we are going to implement inside our lab. So that is the same thing here also. Cultivating innovators. Group of people working based on one particular project. I can't expect everything from one particular student. All the people, they can share their own idea based on this particular project and sit together and discuss together what is the next step. How do you proceed with the next step effectively? So end of the day, I have to get the result, isn't it? Whatever circuit I have shown to you, there is very simple circuit. If I'm showing very big circuits are available for your mobile phone itself, very big circuit. So whenever we are working with the complexity based on one particular circuit, each and every complexity should be taken by one particular team member, and he must provide solution to that particular circuit. So you just initiate. I will show. It is easy with the simple steps. There should not be any complexity at all, and we must minimize the cost also. If you are working with one particular circuit, we have to consider what is the cost of each and every component, because end of the day, we are the decision maker based on product cost. Okay, so what is the next step? Design resource optimization. Design resource optimization. What we are going to do with the help of design resource optimization? Smart use of design knowledge through information technology. So because of the IT industry, information technology, everything available on the table on your hand. By using your mobile phone, if you are searching for city mapping and water distribution system, you will get a different type of circuits. From that, you can choose best one, and you try whether we can get the outcome. If there is no outcome, you just leave it and go with the another circuit. Otherwise, you can develop your own circuit and implement it. So design resource optimization is a very, very important step in innovation. Because what are the components you are going to purchase? I will show that one also with what are the components we are going to purchase and how to minimize the complexity with a very simple diagram. So this one PCB I'm showing to you. Okay. You just think about how many components are there in this particular PCB alone. So what I told you, design optimization resources. Design optimization resources. You just see this particular circuit, how many components are there? Can you count now? Not possible. So many components are there. The PCB design itself one of the toughest task. When we used to work in electronics lab, there will be one general PCB board. By using general PCB board, we used to buy some basic components like resistor, capacitor, inductor, transistor, and logic gates. And we used to sit together to design for a radio, ordinary radio. When we studied BECE, by referring different circuits in Electronics for You magazine. Electronics for You magazine is available from the day itself. I used to purchase Electronics for You magazine hard copy only. So I used to refer all these circuits and I used to sit together with all our classmates. So what is the outcome based on each and every circuit? But nowadays, students are joining in IEEE. They used to receive IEEE transaction as well as magazine. But they will throw in the classroom. I'm so sorrowful. When I was working with the students in the engineering college, they'll throw simply all IEEE transactions and magazines inside the classroom without studying not even single page. Then no use. So now coming into optimization of the design process. So if people are giving one particular circuit and they are asking you to develop like this PCB and they are asking you to assemble all the components in the PCB. Assembling itself one of the toughest tasks to each and every individual. You just see the component size, very, very small. People are developing nanoscale component. The electronic industry, because of the very fast development and the optimization process taking place, very huge. So how do you design these type of PCB and how do you assemble all the components in the PCB successfully? One of the toughest task. Okay, so in your optimization process, this is one of the important domain for electronic engineers to concentrate and to develop PCB. Okay, so the next one, what is the next step? So the next step going to be 3D design, virtual prototype. So whatever I've shown to you, that is going to be your virtual design, virtual prototype. The virtual prototype is nothing but simulation, 3D design. You just design and see the results. Now you just see the PCB also. Some variety of PCBs are available. As an electronic engineer, how we are going to manufacture PCBs, and how do you optimize the technology in that 3D design. So just to see this one also. So this is your PCBs. Do you think it is a single layer? Not at all. Whether it is a two layer? Not at all. So there is a single layer PCB, two layer PCB, three layer PCB, four layer PCB, and a five layer PCB, six layer PCB. Like that, it is increased. So how many components are available in one particular PCB? How you are going to design PCB itself? One of the major tasks. A two layer PCB itself, one of the major tasks. Single layer, it is easy. We can do it in our lab itself. Double layer, little bit tougher. Three layer, then again there is a process. And four layer, five layer, six layer, like that it will be going on. So that is hardware optimization. So in the 3D design, I can do all these things very easily, and we can see virtually what is our five layer PCB, and what are the different layers are available, and what is there, and how we are going to connect all the components together for one particular function. Okay, so like that we have to proceed. And the next step, so this is going to be the final functional evaluation and simulation analysis. See, for all these things, we need a continuous thinking process. What is the function based on one particular design or one particular circuit? How we are going to implement in real time? So if you are doing a functional evaluation, each and every step, for example, I will show that one to you with one image. So how people are working, functional evaluation. So this is a one simple process. Okay. So here what people are doing, each and every stage they will verify the voltage and current rating and voltage rating, because for all the components there is a range. Voltage is fixed. I have to use 5 volt only. 5 volt only we have to use. If you are increasing voltage more than 5 volt, automatically that particular component damaged. While doing this type of testing by using manual process, you can see he has one two hand, and one is based on positive terminal, another one is based on negative terminal, and he is using the multiplier. Okay, so now by using the multimeter we can see what is voltage available. Nowadays, because of the complexity in the circuit, if you are touching two nearby terminals, that is going to be your short circuit. We must be very careful while doing this type of test. That is evaluation process, functional evaluation process. So many functions are available. Every component should be tested properly. See, there is a electronics test and development center in our country. Electronic test and development center. What is their work? They used to test each and every component multiple times with multiple parameters. We can't release a diode component just like that in the market, not at all possible. They have to certify this component is okay, and there is international standards. It must meet all international standards and the IEEE standards. If you are developing prototype, whether that particular prototype is met with all IEEE standards, these are all very, very important steps for doing the functional evaluation. Okay, so the next, so I think you know very well what is electronic engineer, what is their responsibility in the field. Okay, so design the circuit schematic and design the printed circuit board and evaluate and debug the prototype, program the microcontroller. Okay, if you are using the microcontroller, program the microcontroller, then design the enclosure. So body will be, we can't keep just like that outside. It will be enclosed properly. So now you just, I will show one more block diagram to you. So just to see one block diagram. In most of the electronic circuits, it consists of different block diagrams like this. Okay. So what is our aim? Why we need block diagram? It is very difficult to design without block diagram. That's why when students are starting with developing one particular project, they must draw in their own block diagram. Nowadays, what people are doing, most of the students are doing, they'll go with the project center and whatever they are giving, they will accept it and they will come and show to us. It is very, very bad habit. You forget all your project center. You have capability. You must do it in your own by understanding from the electronics for you magazine or electronics or IEEE transactions or IEEE magazines. Plenty of resources available, but we are not using at all. If you are referring all these things, definitely you can draw block diagram in your own like this. So you just see the block diagram. I will explain a block diagram, whatever I'm showing to you. You just see there is a microcontroller. The microcontroller going to be CPU, Central Processing Unit. So if I'm telling Central Processing Unit, so for microcontroller, what is required? Battery level monitor. I have to give some voltage. From when I can get that particular voltage? There is a lithium battery. So what is the output based on your lithium battery? 3.7 volt. You must fix voltage level based on the requirement. And you just see the lithium battery getting input from battery charger. So what is the output based on your battery charger? There is a 4.2 volt. So with the help of lithium battery output is going to be 3.7 volt. So there is a decrease in voltage. Okay, 0.5 volt decrease. And what about your micro USB connector? With the help of micro USB connector, what is the output voltage is available there? 5 volt. And what about your LDO? 3.3 volt. Then UART is nothing but universal asynchronous controller, and it is connected with the help of Bluetooth and Wi-Fi. So there is a temperature sensor, 12 degree centigrade temperature. So temperature sensor is available to monitor microcontroller temperature. And there is a programming connector, and there is accelerometer that is connected with the help of your microcontroller, and there is a display unit, and there is a GPS circuit also. So this is entire block diagram. Now, how we are going to verify with all these things? So for that, you just to see I think all these steps I explained to you. And next, whenever we are working with the R&D team, what are the steps we should follow? So I'm giving one block diagram to you, and I'm drawing one circuit diagram also, and how to proceed with the R&D workers. So data about the performance of the innovation they are creating and marketing. So what are the data available? For example, in the block diagram, I showed you all voltages in this particular range only. So if there is a decrease or increase, it will damage the entire circuit. Don't think only one component it will damage. One component failure leads to another component failure. In electronics, this you should understand very clearly. Inputs they are using into the innovation. What is your input voltage based on one particular component? What about next one? Stage by stage analysis. So I told you 5 volt, the next one 4.2 volt, the next one from the lithium battery 3.7 volt. So there is a difference between these two voltage ranges. It should be maintained. If there is increase in voltage, and it will be given to your microcontroller circuit, then if there is increase in voltage, automatically failure rate will be very high based on that particular component, and if there is failure based on particular component, then entire unit will be fault. So at this point, I want to share one information to you. When I was working with the service industry, we used to service fax machines. So fax machine, it has one microcontroller with 48 pins. How many pins are there? 48 pin microcontroller. One of my colleague, while doing servicing, by mistake, okay, I think I showed you one positive probe and a negative probe. So while doing a testing by using ordinary multimeter with a positive probe and a negative probe, he just touched one pin to another pin. So what happens? Short circuit. Because of short circuit, that particular microcontroller IC burned. Then entire fax machine damaged. So you just think about customer. So we must be very careful while doing testing and also service. So inputs they are using into the innovation, and information about similar innovations evolving. Whenever you are going with a patent, for one particular idea. How many people patented same idea with the same novelty, same innovation? You just search through your Google search. There should not be any similarity. Your circuit must be different from others. And you must be able to explain properly all these steps involved based on the particular innovation. So if you're thinking about government policy, that is existing government policies that affect both innovation, development, and its diffusion. There should not be any class at all. And constraints of adapters in using the innovation to solve their problems. So I told you so many ideas to you. You can touch all the ideas with the different innovators. Different innovators already filed few patents based on the same idea. Whenever you are developing one particular concept, one particular technical concept, we have to put our maximum effort to find the solution different from others, and you must be capable to explain neatly. Okay, so that is R&D related work. The next one, so what about previous scientists did in this area? Now the first step going to be, okay, process of adoption. The first step, awareness of the existence of an innovation, then conviction of usefulness, acceptance in the sense of willingness to try the innovation, and the complete adoption. So 5 stages of adoption process. Number 1, awareness, interest, evaluation, trial, adoption. So 5 functional stages: knowledge, persuasion, decision, implementation, confirmation. The model contains 3 major divisions: antecedents, process, consequences. The next one, what about knowledge? There are 3 types of knowledge. Number 1, awareness knowledge, how to knowledge, then principle knowledge. Okay, sometimes I can work with the same idea. Sometimes I may discontinue, because if there is no innovation, no novelty, then immediately discontinue and proceed with the next idea. If you're thinking it is possible for me to continue the same circuit and I can implement with a different concept, then you just proceed with the same idea and you just modify different circuit, try. If you are getting result effectively, then proceed with the patent and publication. Okay, so this is next slide is going to be only 4 words. What are the 4 important words? It will be revolving in your mind. The first one, idea. Okay, the first step here, idea. The next one, build. You got idea, immediately you must initiate with the what are the requirements, what are the components required to implement this particular idea. You can do trial and error method also. After getting some idea, you can focus on a particular idea and you can you just complete product development by using the same idea and by using the circuit used by other people. Because whenever we are initiating, there may be some clash, but after few days, the same idea can be converted as per your own thinking, because you are thinking continuously. Because you are thinking continuously and you are focusing continuously based on the same idea with the new innovations. Novelty will be introduced by thinking continuously. So build. And what is the third step? Then launch. After modification, that may be different from the existing one. Then you are going to launch. Then fourth step is very, very important, learning. Learning habit should be continued at any cost. You must learn, you must refer. Those who are studying electronics and communication engineering branch, because we are different from other branch students. How we are different? We are concentrating. We are the pillar for all the branches. They are depending upon us. I think all your automobile vehicles, if it is converted into e-vehicles, who is the major people? Electronics and communication engineers are major people. Their contribution will be highest. So for this, we must have hobby of continuous learning process. Learning never ends. Okay, it is a continuous process. If you are learning so many books, for example, as per your recent thought process, people used to learn first page and in between page and in between page, and they leave in between. There is no continuity at all. If you are learning line by line, and there will be continuity. Same thing in your circuit also. We must verify in the PCB each and every point. Each and every point is very, very important based on voltage ratio, current ratio, and the electric field and the magnetic field. Okay. Then the next one. What is your day 1, day 2, day 3, day 4, day 5? Most of the student, well, starting with one particular idea, you must plan accordingly. What is your day 1 step? What you are going to do? For example, if I'm taking one particular idea and I'm focusing with that particular idea, and I'm going to draw circuit diagram today, I must complete circuit diagram based on this particular idea. Like that, you should focus. And you must distribute work also. If there is 4 different members are there in that particular idea, all 4 different members should share their idea. I'm going to do circuit diagram part. I'm going to support you. What are the components required and where it is available, I will purchase all the components, and another person will be doing only assembly. Circuit diagram is your base. The next step going to be what are the components required and how do you do assemble in the PCB, and what are the components you are going to purchase. With the cost analysis, you must do cost analysis also. Cost analysis, very important step. We can't spend a very huge amount. Cost minimization is one of the major factor. We should not develop expensive circuit. Okay, so start to focus solution. Day 2. Start to focus on solution. Review existing ideas, then improve by chopping and changing. Okay, so what is the idea and what are the existing ideas, and you just compare with all the ideas, all your competitors, and you just cut down. Okay, so potential solutions individually, that is individual focus. The next one, review the individual solution as a group and decide which have the best shot. So as a group, turn the best solution into step-by-step plan for a prototype. So if I am telling prototyping, in ECE, there is so many domains. Students are concentrating with the electronic circuits, and slowly they will concentrate with the electromagnetic field analysis based on that particular PCB, and they will think about how to assemble antenna for wireless communication system. How do you design antenna? Prototyping antenna also one of the major domain. And nowadays we are getting all the signals just like that. Okay, we have to design proper antenna, then only it is possible. Signal strength. So step-by-step plan for a prototype. Then day 4, what we are going to do? Act out the prototype plan and develop a realistic stand-in for the end solution to test with customers. For example, dummy software interface. So in the last workshop, I told you Alan and Microsoft owner Bill Gates, they tested with the hardware and software interfacing. They got failure initially. Later on, by thinking continuously, they got success. That is their first step to proceed with the business. Finally, test the dummy prototype with the customers. By learning from the reaction to the prototype, you have shortcutted the typical testing process. So once they traveled and demonstrated to the company, they didn't accept anything, but while returning, they got different idea and they implemented, and again reached the same forum and demonstrated everything successfully, and they got success. So like that, we have to proceed with the different ideas. Okay, so day 1, day 2, day 3, day 4, day 5. So this day plan. And what about your innovation matrix? So what is your basic research, where both problem and the necessary skill domains are both in need of clear definition. Then destructive innovation, where the problem is not well defined, but the skill domains required to solve it are known in detail. And the next one, breakthrough innovation, where the problem is well defined, but necessary skill domains require further definition. Sustaining innovation, where the problem and skill domains needed to solve the problem are both well defined. Okay, so the next only 3 slides are there. That is step 1, defining the process requirement, and step 2, designing the process, step 3, implementing the process. Okay, so I think so time around 8 to proceed with the question and answer also. So at this stage, with 3 steps, okay, step 1, step 2, and step 3, defining the process requirement, then designing the process, then implementing the process. Okay, so like that we can proceed. If there is any questions, you can ask. Thank you so much for your kind patience. Students, I think feedback is available in your chat box. You just fill the feedback. Feedback is very, very important. Okay, you just fill the feedback, and if there is any questions, you can ask, and you can communicate through chat box also. I'm ready to answer to you.
Thank you, sir. Thank
Uh,
you, sir, for your stimulating and fruitful session. Now I handle the question and answer session to Gayatri.
Let's move on to the question and answer session. How can we spot opportunities for innovation, sir?
okay, so opportunities based on innovation. So in the last workshop, I shared few links for electronic student. For example, circuit today. You can refer circuit today, and so many circuits are available. Plenty of circuits are available. Only thing we have to provide a solution. So if you are referring different circuits, automatically we can get opportunity to solve different problems. We can think so many ideas, but end of the day we have to implement it in real time. To focus one particular idea, we have to refer different magazines, and we have to get an opportunity to do and implement in real time. So if you are proceeding with like this, definitely it is possible for us. I told you ordinary wristwatch, digital wristwatch, and nowadays the complete health monitoring system. I can monitor your temperature, I can monitor your heart rate, I can monitor your BP level, I can monitor your oxygen level, everything integrated together. Only thing you should focus to understand how people are integrating all these circuits in one particular PCB. Okay, so you have to create opportunity to study all these things. Next question.
Sir, thank you, sir. Now it's time to express our gratitude. On behalf of Electronics and Communication Engineering, St. Joseph's Institute of Technology, St. Joseph Group of Institutions, I thank Dr. G.S. Udaykumar sir for enthralling speech on process of innovation development and technology readiness level and commercialization of lab technologies and tech transfer. Thank you, sir, for taking your time from your busy schedule and joining us to share your knowledge. My heartfelt thanks to our beloved chairman, sir, Dr. Babu Manoharan, to organize a wonderful webinar for gain knowledge about commercialization of lab technologies and tech transfer. My sincere thanks to our managing director, ma'am, Ms. B. Jessie Priya, and our director, sir, Mr. B. Sasisekar for their guidance in conduction of the webinar. I would like to express my gratitude to our principal sir, Dr. P. Ravichandran, for his support to conduct this webinar, and our department heads, Dr. C. Nyanakausalya ma'am, staff and student affair, and Dr. G. Rohini ma'am, lab affair, for their words of encouragement and guidance, and our department staff and the organizing team for arranging this webinar successfully. And finally, my sincere thanks to all the participants for your active participation and support. Thank you all.
Okay, thank you so much, students. If you want to interact, you can interact and you can ask your questions. I am available another 15 minutes. You can share, you can interact with me if you have any clarification. If you need any clarification, students, you can ask any questions if you need any clarification based on our explanation.